let's see how we can build a product search engine with Ultralytics. So we can pretty much just have a bunch of different images that we have in a folder. We can then do embeddings on all the images and perform some similarity search on top of it. So that pretty much just means that you can have a folder of images and you can ask it to pull up images of specific things. So you can basically just prompt it and it's going to find similar images to what you're prompting. So this is pretty much just a model finding features in our images, then we get them into an embedding space, and images being similar could be images in sunlight, could be images with snow, cars driving outside, images inside. All these different images, they will have some similarities that our feature extractor or embedding model is actually catching, and then they will be closer to each other once we get them into embedding space. So let's just jump straight into the Ultralytics website here. We will go into the documentation. We will see how we can build out this with just pretty much just a single line of code based on a folder. We can build out a whole product catalog that you can just search for and it will pull up those images. So if we go inside our solutions tab, all the way at the bottom, we can see we have this new one, similarity search. We have a video already covering like how we can do visual search using like the OpenAI clip, the Meta Facebook AI similarity search model. All these different ones here where we have the app and we can search for. Here we dive a bit more into details about the embeddings, how they're working and so on. So definitely check that one out. But pretty much just we use a vision encoder, we get the embeddings, we can search between the embeddings, and you can also have like visual text embedding pairs, so you can search specifically for specific words. All we have to do is basically just from Ultralytics import solutions, we can create our search app, we specify our data directory. This can both run on CPU and GPU. It will run faster on GPU, but this can also be used for CPU. We just need to build it out once. So we're building out a database with all our images, and each image is described by embeddings. So it's basically just a numerical vector in an n-dimensional space. So let's say that we have like, let's just say 100 numbers in our vectors. So that's a 100-dimensional vector, each value describing some feature in our image. Then we can do cosine similarity search. So this is just finding the distance between the vectors in our n-dimensional embedding space, and if there's some similarities, they will have higher score because the distance between them are smaller. So let's just jump straight into our code editor and see how we can do it. So I have a folder with some fashion images. So this is how we can build out a product search engine. So we just have a bunch of different images. Here we have a soccer jersey. We have different product images. You can use whatever you want, and then we're going to build out our image search engine pretty much. So we have all these product images. Right now, we just specify our fashion images. This is our dataset folder. The device, CUDA, only have CPU available on this computer, so we're just going to run with that, and we're just going to run our app. Let's open up the terminal. So Python, semantic, search fashion data. It's going to build this Facebook AI similarity search index for our images. It will take some time here on CPU as well, but it's just going to build out the database for it. Might take 10-15 minutes. We have a lot of images in our database here. Once that is done, we can open up the app pretty much, and we can do similarity search on our full data set. So this is very important if you want to find edge cases, if you want to do data exploration before you're training your computer vision models. You have all your labels, maybe you have unlabeled data, you want to find specific edge cases, you're trying to come up, build a full self-driving cars, you can see your car is performing worse when it gets direct sunlight into the cameras. We might actually be able to go in and search for those specific examples that we are training on, or maybe we have some unlabeled data. We try to make our model better for this edge case. Let's just go and do similarity search. I want images in direct sunlight. It will pull those images. I can then take those images, label them, put it into our full data set, retrain our model, and then it's a very big part of the model iteration loop as well. So let's just let it run here. Let's get back to it, and then we'll do our similarity search once it's done. So this took around 10 minutes to actually just index all the images. We can see we have indexed 43,000 images, and this was just running on a CPU. So now we have our Flask app up and running, and we can now open it up. There we go. Now we have our semantic image search with AI. If we go back into it here, we pretty much just have a few examples that we can test out. So try to see if we can actually find Adidas t-shirts. So we can search for very specific things, and this is very cool if you have like a product catalog or whatever you want to do with it. There we go. Adidas, 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 all of them are Adidas. Even this one here, you can just only see the logo. It's even the exact same color as the shirt. This is the top 5. You can specify if you want to use the top 5, 10, 30, and so on. This is all the Adidas t-shirt images that we have. What about if we only search for Adidas? Now we can see we get more results. Go for top 30. Now we both get all different backpacks, socks, shoes, t-shirts, all these different products that we're pulling up. So instead of just searching for like text-based search and so on, we can also do search directly on images. You can see the backend here is running. So this is just a Flask server running. So you can pretty much just build any application around it. Let's try to see if we can find some of the other ones. So wallet in brown color. And you can see how crazy fast it is. So right now, I'm going to type it in, search, and it just instant pulls it up here. You can see how fast the search results are, even though we're doing it on images. But the images are actually like just numerical values that we're searching on, so it's still crazy fast. So these are the brown wallets that we're able to pull up. Bike logo, t-shirt with bike logo, pretty detailed one as well. Search, we have a bike here. This is pretty cool. I'm not sure if this is a bike. Maybe the AI is smarter than me. We can see a small bike down here at the bottom. And this is filtered based on the similarity score, so we might be getting some results here which has lower similarity. So you can see we still see some bikes here. Here we have a cowboy, we have a bike down here at the bottom. So this is pretty cool. It's very instant. You can build out an app around this. You can find all the source code and everything inside our GitHub repository. This is just running on our backend with a quick front end as well with Flask. You can build this into your own product applications, your own web applications. Could also be that you just want to use it locally to find edge cases for your computer vision pipeline and dataset that you're building out. This can be used on any set of images. This is just one fashion image folder with 50,000 images. Could also be smaller examples. Maybe you have 10,000 images for some specific custom dataset that you're building a computer vision application around. So this is pretty cool. Definitely go and check it out. It's just a few lines or pretty much just one single line of code, and you have it up and running. Hope to see you guys in one of the upcoming videos. Until then, happy searching.